Guys, I hope everyone is doing well and healthy. Hope you had a great weekend. Before we get into some questions on the quiz review, I wanted to clarify what you're going to see either tomorrow or Wednesday, whenever your class is. You'll be receiving an email to your Google Classroom email, so the .NET account from me with a Google form, which is the quiz, just like what we've seen in the past, what your formatives have been, what your quizzes and tests have been. So it's a Google form plus an additional PDF. So instead of you guys drawing out, the circle or the chart, some of you may have to if, say, your printer's not working or whatever it might be. So this is just one document, and there's going to be a question on the quiz that says, let's say, fill out this chart. Well, I have the chart already on a piece of paper, so all you have to do is fill it in and then upload it, okay? Or if you can write on it, you could, on the PDF, you could do that as well. There's also a unit circle, as you know, will be uploaded. Um, so that's on the document. So it kind of keeps everything all together. However, for you guys, it makes it easier so you're not writing out everything and it's easy to upload. Okay, so if you're able to write on the PDF, you could just upload it in the one spot and hopefully you should be good to go. Okay, if not, just let me know and upload it twice if you need to. So we're trying this a little bit different, and it will be during your class time that we're doing these quizzes because there's too many people I've been chasing down for formatives and for quizzes to complete. So it's during your class time. It will count as your attendance to be completed. Okay, so a few of the questions that I got regarding the trig review, just to kind of clarify this chart here. They're giving you an angle in degrees, coterminal angle. So we're saying coterminal in between 0 and 360. You're given a specific angle that's probably greater than 360 or less than 360, which they want you to kind of refer back to the unit circle. So it's from 0 to 360. Your reference angle, which is either 30, 45, or 60. The exact value of cosine, which is your x, sine, which is your y, and tangent, which we're going to review, is y over x. So I'm just going to do two from the chart so you know. Okay, so we have an angle in degrees of 690. Well, to see where it falls within the unit circle, we subtract 360 and we find out that it's 330 degrees. That is in quadrant 4. That's based off the unit circle. The reference angle, you look at the x-axis it's close to. This one is close to 360. 360 minus 330 is 30 degrees. Okay, and you look at that coordinate point, which is root 3 over 2 and negative 1/2. Root 3 over 2 is your x value. Sine is your y value, which is negative 1/2. Now to find tangent, okay, it's y over x, so it's sine over cosine. This is what it would look like if we did it out completely. You have negative 1/2 over root 3 over 2. You multiply top and bottom by the reciprocal, so multiplying by 2 over root 3, top and bottom. Your denominator cancels out, and also your 2's cancel out. Okay, so when all it's said and done and simplified, you end up getting negative 1 over root 3. Cannot have a radical in the denominator, so you multiply top and bottom by root 3, ending with negative root 3 over 3. So that's what we get for this, for tangent of 690. Okay, then another one that I did for you was a negative angle where you add 360 and you get 300, which is in quadrant 4. Closest x-axis is 360 minus 300 is 60 degrees. That coordinate is 1/2 and negative root 3, which is x positive, for cosine, y is negative for sine, and tangent is y over x. So negative root 3 over 2 over 1/2 multiplied by the reciprocal. 2's cancel, so you end up with negative 3. So I hope going through those two problems, it'll make a little more sense to you. Obviously, if it's greater than 360, you keep subtracting until it's within 0 to 360 degrees. Okay, a lot of you had questions on 2 through 5, so we're going to go through one of each. Now, when they ask you these questions, we rationalize, so all your answers have to have no square roots in the bottom. They keep the square root in the bottom because it's a practice problem to know. Okay, so they're telling us that suppose theta, which is your angle, is between 270 and 360. Well, what quadrant is that in? 4. So in quadrant 4. So I draw my little triangle here. In quadrant 4, my x is positive, my y, oops, is negative. Okay, so they're telling us cosine is 2 over root 6. And your angle always comes from the origin. So cosine is adjacent over hypotenuse. So this is 2 over root 6 is your hypotenuse. So they want us to find sine. So we're looking for that side length. Now ask yourself, since this isn't quadrant 4, okay, we have to decide the sine once we get to that point. But before we get to that point, we need to figure out this side length, which we use Pythagorean theorem. So 2 squared plus b squared equals root 6 squared. Okay, so when you use Pythagorean theorem, you end up with b squared equals 2. You take the square root of both sides, and you get b equals plus or minus 2. Now, it's plus or minus because we took the square root, so those are the possible values of your missing side length. However, we're in quadrant 4, so what is this missing side length going to be? Positive or negative? Well, it's in quadrant 4, so this is going to be, we're going to have negative root 2 for that side length. Oops, missed a side length there. So now in order to find sine, okay, to find sine, I'm going to erase this real quick. To find sine, it's opposite over hypotenuse. So it's negative root 2 over root 6. Again, we cannot have a radical in the denominator. Multiply top and bottom by root 6. So here you get negative root 12 over 6. However, it can be simplified, square root of root 12. So we have negative 2 root 3 over 6, which then can be simplified to negative root 3 over 3, which is your sine value. Now, back here, we could have actually reduced it from the beginning since you have a square root top and bottom. This whole fraction could have been under the square root. So we could have reduced from here to 1/3 and then rationalized. But no matter what, you would have gotten sine is negative root 3 over 3 for that one. Okay, so number 4 and 5, so 3 is just like the one above. Okay, however, now you're finding tangent. Number 4 and 5 are similar as well. We are trying to find out the possible values. So that is key. Okay, and they're telling us sine of theta is equal to negative 3 over root 11. Well, where is sine? negative. Root quadrant 3 and quadrant 4. That's where sine is negative. So they're not telling us what quadrants it's in. So right now, based on what we're given, it could be in either quadrant 3 or quadrant 4. Okay, so when it asks for possible values, you're going to see why. So again, draw your triangles. Well, I know it's in quadrant 3 and it could be in quadrant 4. Okay, sine is opposite. So I know this is negative. I know this is negative, and this is root 11. This is root 11. Your hypotenuse is always positive. So now we have to find this missing side length, which is our x value. Well, you run Pythagorean theorem like you did above. So you would have negative 3 squared plus b squared equals root 11 squared. So when you do Pythagorean theorem, you're going to realize we end up getting b equals plus or minus root 2. Well, in the third quadrant, is this side length positive or negative? Well, it's negative. In the fourth quadrant, is this value positive or negative? It's positive. So right now, you see we could have two possible cosine values and two possible tangent values. So cosine is adjacent over hypotenuse. So cosine right now of theta is plus or minus, because it could be either, root 2 over root 11, rationalize, and you end up getting plus or minus root 22 over 11. Okay, root 22 over 11 for cosine. Now tangent is going to be the same thing. However, tangent is opposite over adjacent. So we have plus or minus 3 over root 2. Again, you rationalize, so you end up with plus or minus 3 root 2 over 2. Okay, so that would be the same thing for number 5. Possible values, you will be including plus or minus for both, because sine is positive in this case in 2 places. All of them are. Cosine, sine, and tangent are either positive in 2 places or negative in 2 places. So again, pay attention to the quadrants, look at the quadrants, draw yourself a picture if you need to, but hopefully that answered your questions 2 through 5. Okay, so no one requested this question to be done, but just to clarify, because you did have one as a warm-up, so that's probably why. But if you are given a point that lies on the terminal side, which is where you end up of an angle in standard position, find the values of cosine, sine, and tangent. So you look at the point. Here we're given negative 1, 5. Well, what quadrant is that in? That's quadrant 2. Okay, so this is very similar from what you did on the previous page. However, they're not giving you cosine, sine, or tangent value. You have to find that. And we find that by using Pythagorean theorem. So this is in quadrant 2. Oops. Let me just erase that. It's not a good one. Okay. So it's in quadrant 2. Draw your little triangle. Okay, hopefully yours is better than mine right now. Negative 1 and 5. Okay, I know it's negative 1 because that's my x value. 5 is my y. And then quadrant 2, your x is negative, your y is positive. So you have to run Pythagorean theorem to find your hypotenuse. All right, so I made that triangle a little bit better so you guys could see it. So once you run Pythagorean theorem, you end up with a hypotenuse of root 26. So from here, you're finding sine, cosine, and tangent. Okay, sine, cosine, and tangent. And again, cosine is your adjacent over hypotenuse. So that one, if you look at the key, was negative root 26 over 26. Sine is opposite over hypotenuse, so this would be 5 root 26 over 26. Tangent is opposite over adjacent, so you end up with negative 5. Okay, so I hope that helps going through at least one of them, but it's very similar to what you saw on the previous page. You're actually finding cosine, sine, and tangent given a point. Okay, this whole section, I know the review questions came out a little strange. Actually, let me go back here for a second. Someone did request number 8 and 10, but again, they're very similar. So I'm going to do number 8 over here. Negative 3, negative 4. So they're both negative. That's in quadrant 3. This is negative 3. This is negative 4. You run Pythagorean theorem and you end up getting a hypotenuse of 5. This is actually a 3, 4, 5 triangle. So for cosine is adjacent over hypotenuse, so negative 3/5. Then we have sine, which is opposite over hypotenuse, so negative 4/5. And then you have tangent, which is opposite over over adjacent, sorry. And it should be positive because you have a negative over a negative, which gives you a positive. So that would be, you would do the same thing in number 10. You have negative 3 and 1. That's in quadrant 2. Okay. So for this next section, all you're doing is measuring in radians. You're literally converting it. It doesn't matter if it's negative, positive, whatever it might be. You are just converting it in radians. So for example, 15, it's negative 150. So since I need to convert it to radians, I'm going to have pi over 180. And again, remember this, you're just literally tacking on pi. So we have 150 over 180 pi, and you want to reduce. So this would end up getting, what can you reduce by? Well, first you could cancel out the zeros. Okay, so negative 15 over 18, 3 goes into both of those. So you will end up with negative 5 pi over 6, or negative 5/6 pi. Okay, so in this section where it says just convert to radians, that's all you're doing. You're not going any further. Same thing down here. When you write each measure in degrees, okay, when you write each measure in degrees, you are converting from radians to degrees. So for example, if we had pi over 6, we multiply by 180 over pi, ends up canceling out. 180 divided by 6 gives you 30 degrees. All right, well, these 3 questions did come up, okay, and it's saying the measure of theta of angle and standard position is given. Find the exact values. So exact values are definitely going to be from the unit circle, which can be root 3 over 2, 1/2, root 2 over 2, We could have, those can be positive, negative. We could have negative ones, 1, 0. We could have, if it was tangent, root 3 over 3, negative root 3 over 3, or just root 3 or undefined. So here we're only looking for cosine and sine. So for 23, pi over 6, that's actually on the unit circle. So that is 30 degrees. Okay. So pi over 6, we know, is 30 degrees based on the unit circle. So what is cosine? Well, cosine is your x, sine is your y. So cosine is root 3 over 2, and your sine is 1/2. Okay, so this is your cosine, and there's not a lot of room for me to write this, but I'm gonna make do. Sine is 1/2. Okay, so the cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. So now for 25, we're looking for the sine and cosine of 7 pi over 4. Well, 7 pi over 4 is the same as 315 degrees. So 7 pi over 4 is on the unit circle. So your cosine is root 2 over 2, and your sine is negative root 2 over 2, since it's in the fourth quadrant. Okay, for 27, I moved to a separate page so I could show you. This is negative, okay, and it's in radians. If I was to convert it to degrees, excuse me, it would be negative 120, okay? And to figure out where it falls in the unit circle to find the exact values, I would add 360. Well, since it's in radians, in order to get between 0 and 2 pi in radians, I would have to add 2 pi. Well, I can't add 2 pi because I need a common denominator. So my common denominator, I'm going to multiply top and bottom by 3. So instead of just 2 pi, I'm going to have 6 pi over 3, which gives me 4 pi over 3, which is equal to, if we wanted to know in degrees, 240 degrees. So my cosine negative 1/2, my sine negative root 3 over 2. Okay, and this is where the second part of that Google form, or actually third part of that Google form, where it started with 12 again, the numbers were out of whack, so that's why I started it in a separate section. And at first I forgot to include have no questions. Um, so again, if you had no questions, sorry about that. But here it's saying you want to find a measure of an angle between 0 and 360. So they want you to work backwards. They're giving you either a positive or negative coterminal angle, and they want you to find a degree that's positive between 0 and 360. So we want to see, let's start with number 12. Well, it's negative. So in order to find where it falls within the unit circle, I'm going to add 360. So once I add 360, I get 260 degrees, which is a coterminal angle of negative 100. It's a positive coterminal angle. negative 100. It might not be an exact degree that we have on the unit circle, but it falls within that range of 0 and 360. Okay, let's see. Another one was 18. So 482, that's greater than 360. So I want to subtract 360, and I end up getting 122. So again, they're just asking for the coterminal angles, okay, of these. They're not asking for exact values because you would need your calculator to find out the exact value of 260 and 122 because it's not a specific point on the unit circle. All right, for this section here, again, you're just finding the exact values. If it's negative, you add 360. If it's greater than 360, you subtract. Okay, now 55, 57, 58, and 59, you're finding a positive and negative coterminal angle. So if we look at 57, and I listed two negative coterminal angles because they both would work. So I could either subtract 360 to get negative 1040. If I added 360 one time, I'm still in the negative zone, which means I will have negative 320. Okay, so that's also a negative coterminal angle. So in order to find positive, I would just add 360 one more time to find a positive coterminal angle of 40. So your two negative coterminal angles, in this case, the reason I showed you two of them because some of you might list both. So one would be negative 320 or negative 1040 for negative coterminal angles. They both are acceptable. A positive coterminal angle, I would add 360 again, and a positive would be 40. If I added 360 again, I would get 400 as another positive coterminal angle. Either of those work, okay? If you just listed negative 320 and 40, you would be correct. If you did negative 1040 and 40, you would also be correct. So positive coterminal angles, just remember you're adding 360. For negative, you're subtracting 360. Okay, before I get to this next section, I actually want to review if it was in radians. So for example, if I wanted to know a positive and negative coterminal angle of 2 pi over 3. If I wanted to know a positive and coterminal angle, automatically you would either add or subtract, depending on which one you're looking for, 2 pi. But we cannot multiply by 2 pi because we have a denominator here and this is over 1. Denominators do not match, so therefore we need to find a common denominator, which is 3. So you then multiply 2 pi by 3 to get 6 pi and 1 by 3 to get 3. And then you add together and you get 8 pi over 3 as a positive coterminal angle of 2 pi over 3. If I wanted to know a negative coterminal angle in radians, I would subtract. Same value as what you see. 6 pi over 3, which gives us negative 4 pi over 3. Okay, so again, look at your denominator, see what you have to multiply by, because it has to equal 2 pi, which is 360 degrees. So if I had 3 pi over 4, and I wanted to find a positive or negative coterminal angle, I would be adding by or subtracting by 8 pi over 4, because that gives me 2 pi. Okay. If I wanted to know of, let's see, 5 pi over 6, I would add 12 pi over 6. Okay, or subtract, depending on what I'm looking for. So you're looking for these denominators to be the same in order to add or subtract. Okay, now if we look at this last section here, 61 through 64, they want to know what quadrant they lie in. Okay, so if we look at negative 7 pi over 3, well, that's negative. So in order to make it positive, we have to add, well, it's denominator 3, 6 pi over 3. Well, look at that. We're still negative. So we have to keep going. We still have to add another 6 pi over 3. So you add another 6 pi over 3, and you end up getting 5 pi over 3, which is in quadrant 4. Okay, because that's 300, so it's in quadrant 4. So for 62, you would add 360. Okay, you would add 360 to get 120, which is in quadrant 2. 5 pi over 4 is an actual angle on the unit circle. That is 225. So that's quadrant 3. Now, if you took 540, and subtract 360, you end up getting 180, which is not in a quadrant. Okay, it's the x-axis, excuse me. So there's no quadrant available for 540. Okay, I hope that helps. Okay, going through this review. Okay, a few of you have asked if there's any shortcuts to filling out the unit circle. Well, a few things I would do is fill out your quadrantal angles first, which is 0, 90, 180, 270, and 360. Okay, and fill out those coordinate points. Remember, you have a radius of 1 all the way around because it's a unit circle. So 0 and 360 is 0, 1. 90 is 0, 1. 0 to 360 is 1, 0, excuse me. 90 is 0, 1. 180, negative 1, 0, because it's opposite that. Opposite 90 is 270, is 0, negative 1. Okay, then you could fill out the degrees. Okay, you could start with going through every 30 degrees. So 30, add 30 is 60, add 30 is 90, add another 30 is 120, 150. So 150, you add another 30 to get 180, add another 30 to get 210, add another 30, 240, then 270, 300, 330, rounding off at 360. Then your next would be 45 degrees. So 45, add 45 to get 90, add another 45 to get 135, add another 45 to get 180, add another 45, 225, add another 45, 270, Another 45 is 315. Then add another 45 is 360. Okay, so once you fill out the degrees, you then move on to the coordinates. So this first quadrant is going to help you with everything else. So again, 30 degrees is root 3 over 2 and 1/2. Okay, 45 degrees is root 2 over 2 root 2 over 2. Then 60 degrees is 1/2 and root 3 over 2. Okay, so this first quadrant we should know of. All right, once you head into the second quadrant, remember you could use your reference angles, meaning they're going to be the same exact coordinate, however, different signs. So it's 180 minus your angle you're looking for, okay, to find your reference angle. Positive is your y value, x is your negative value, okay? So what I just did, if you guys could see, all I did is using technology right now is copying my coordinates and put them where the reference angles are. So I did 120, then I came down here and did 240, then 300. Okay, did the same thing for 45 degrees. Now, if you notice, I'm doing 150. Well, I have root 3 over 2 and 1/2. Well, also 210 is the same thing, as well as 300. So now I'm going to go through and do the signs. Well, in quadrant 1, everything is positive, x and y, so I don't have to do anything there. In quadrant 2, my x's are negative, so I'm tacking on a negative there. In quadrant 3, both are negative, okay? And in quadrant 3, x and y are both negative. And to find your reference angle is your angle minus 180, okay? Then in quadrant 4, my x is positive, my y is negative, so that's negative, negative, negative to fill out your unit circle, okay? So again, we did one unit circle with similar colors, okay? You could do that here as well. You could take out some colored pencils or markers and use the same colors to help you. Okay, the last thing to fill out is radians. So we're going to start with 30 degrees, which is pi over 6. So every 30 degrees you add 1/6. So I'm going to show you the pattern and then reduce at the end. So, and then I'll erase it so you guys could see it. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and we have 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6, and this would be 12 pi over 6. So if you notice so far, before reducing anything, okay, before reducing anything, every 30 degrees has the same denominator as of right now, okay? We're going to reduce in 1 second, which is anywhere you see, okay, anywhere you see a fraction that can be reduced, we're going to reduce it right now. So pi over 6, and then 2 pi over 6 reduces to pi over 3, okay? Then 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. Okay, 5 pi over 6 stays as is. 6 pi over 6 reduces to pi, which all of you should know that. 7 pi over 6 stays as is. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. And 12 pi over 6 is rounding off. Oh, we have 5 pi over 3, then 11 pi over 6, then 2 pi. Fix that for you. Okay, so we went through and did all 30 degrees. Okay, now we're going to do the same thing with 45 degrees. However, we're starting with pi over 4. So every 45 degrees, you're adding 1/4. So at 90, it's 2 pi over 4. Another 45 is 135, which is 3 pi over 4. And then here you would have 5 pi, oh, 4 pi, sorry, 4 pi over 4. Then another 45 degrees, 5 pi over 4. This is 6 pi over 4. 7 pi over 4. And rounding off at 8 pi over 4. So if we go through and reduce, you have pi over 4, 2 pi over 4, which reduces to pi over 2. Then you have 3 pi over 4, 4 pi over 4 reduces to pi, 5 pi over 4, 6 pi over 4 reduces to 3 pi over 2, 7 pi over 4, 8 pi over 4 reduces to 2 pi. So that completes your unit circle, okay? Also remember, all students take classes. So that means sine, cosine, and tangent are all positive in quadrant 1. In quadrant 2 for students, sine is the only one positive because that's your y value. Cosine and tangent are negative. In quadrant 3, your tangent is positive because both your sine and cosine are negative. In quadrant 4, cosine, or for classes, your x value is positive, your cosine is positive, your sine is negative, and your tangent would be negative as well. So hopefully that helps going through the unit circle, and hopefully I answered all of your questions. I'm going to look right now to make sure there's no additional ones on the review that you have questions on. Um, so If you have any additional questions, you could send me an email or you could join the Google Meet at 11:30 for Tuesday's classes and say 9:50 for Wednesday's class. Okay. And if you need any extra help during the day or after school, please send an email because there might be availability that I could squeeze in some extra help sessions for you um, before the quiz. All right, so I'm just going to check if there's nothing else further. You guys can end the video and rewatch it. I will be doing a quick session on 6.2 practice 2. Some of you had questions on that, which I will send a separate video for. Um, but good luck. If you have any questions, please let me know. And also keep in mind that anytime you take an assessment, it's just like if we were in the class, meaning it's not, I expect you not to use your notes, anybody else's help, phone, computer, anything like that. You shouldn't have any additional help, just like if we were in the classroom. So I expect that of you. All right, so keep that in mind when you take this quiz tomorrow. Good luck, you guys.